All right, so here, okay, we're still drawing 5 cards from the deck without replacement, okay? Without replacement. So again, we're not putting a card back. So it's impossible to have repetition now. Also, okay, so what's the probability that only 3 cards are red? Well, again, we don't care about the order either, right? All we care about is whether the cards are red or not. You know, we're not saying what's the probability that we draw this card, then that card, and so on. We don't care about order here, right? And again, red cards are from the suit of hearts or suit of diamonds. So there's 26 red cards, okay? Okay, so from 26 cards, how many ways can we choose 3 with no repetition and order doesn't matter? Well, again, it's combinations, right? It's C of 26, 3. Again, no repetition. We don't care about the order either. Now we don't divide though by the sample size, the total number of outcomes yet. Because we're drawing 5 cards though, right? Well, those 2 remaining cards can't be red. They have to be, from the suit of clubs or spades. So there are 26 other cards they can come from. Those 2 cards can come from, that is, the 2 cards. For the 2 cards, we have 26 possibilities. Excuse me, I misspoke. The remaining 2 cards, there's 26 remaining cards these 2 can come from. And again, repetition doesn't matter, the order doesn't matter, so we have this. So this is how we handle the last 2 cards, right? So this is how many ways we could choose the first 3. This is how many ways we can choose the last 2, right? So by the counting principle, this is how many we can choose. This is how many ways we can choose all 5. Again, you just multiply. That's what the counting principle tells us. Okay. But then how many ways can we draw 5 cards from the deck of 52 cards, where again, order doesn't matter and repetition is not allowed? Well, again, that's combinations. That's what that C of 52(5) is. I just fixed it. For some reason, it was C of 52, 2, but it should have been 5. Sorry about that. So altogether, we get this. Okay. And then again, we just divide and we get this. I mean, here I said round your answer to 4 decimal places, which is why I have this. Okay. That's probability. There's another one we'll do, but are there any questions on this one? Okay, here's another one I got from the textbook, actually. Well, almost all the problems come from the textbook. So suppose here, right, we have a math class. There's 25 students all together. There's 14 females and 11 males. And let's suppose 3 students, they're selected at random because they're going to participate in a probability experiment. In other words, the teacher or whoever is choosing 3 students at random. What's the probability? We're going to compute the probability that, each of these parts we're going to deal with. So for the first one, we are going to find the probability that a male is selected, then 2 females. Okay. Now here, order does not matter. And why is that? Well, because we're choosing 3 students. But it doesn't matter which student we choose first or which student we choose second. The problem doesn't indicate that the first student chosen has to do something different than the second student chosen, right? So in other words, order doesn't matter here. It's not like with those, what do you call it, those elections examples we did where the first person chosen was president, the second person chosen was secretary, something like that. It's not like that. Nothing from the problem is indicating that the first person chosen will have to do anything different than the second person or the third person. So order doesn't matter, in other words. And also repetition is not possible. That should be kind of implied. So again, we're going to use combinations, right? So if we have 25 students, how many ways can we choose 3 students? Well, that's this. This I actually calculated from Desmos. Okay. What about choosing a male, then 2 females? Well, there's 11 males, right? So there's 11 ways we can choose just 1 male. Okay. Now there are 14 females. How many ways can we choose 2 females, right? Again, we don't care about the order. There's no repetition. So for the 2 females, that's what this would be. Which of course is the same as this. Okay, so there are there are this many ways for the first person, for the first, for the first task. There are this many ways for the second task. So in total, for both tasks to occur, we have the product. Again, it's just by the multiplication or counting principle. I think they both refer to the same thing. We have 11 ways of doing the first thing, this many ways of doing the second thing. So the total number of ways of doing both is the product. So the probability then would be this quotient. I didn't calculate that as a decimal, but that's okay. Now that's for a male and 2 females. What about a female and 2 males? Well, again, it's basically the same. We're in the same situation. So again, there's no repetition and order doesn't matter. Okay. So again, repetition is not, we don't allow repetition and order doesn't matter. Well, there are 14 females that we can choose from, right? So in other words, there are 14 ways we can choose the female. Okay, now there are 11 males. We're choosing 2 of them. So we're going to have to use combinations, just like with the previous slide. Okay, so the number of ways we can choose the female and the total number of ways then we can choose 1 female and 2 males, we take the product. It's the counting or multiplication principle. That's all it is. Which turns out to equal this product. Right? Remember the multiplication principle. You just multiply to get the total number of outcomes. So we get this, and therefore the probability is this quotient. Okay, that's good. All right, that's good. What about if 3 males are selected? Well, there's 11 males, right? And we want to choose 3. But again, order doesn't matter and repetition is not allowed, so we use this. So that tells us the probability then that all 3 are males would be this thing. Now, what about females? What if 3 females are selected? Well, there's 14 females, right? That's given. So how many ways can we choose 3 females out of 14 without repetition and we don't care where order doesn't matter? That's what this is. So the probability then would be this. Any questions on that? All right. Just pause the recording.